And welcome back. This video is on adding algebraic terms. Okay, adding algebra, and I'm in red. Don't know how that happened, but anyway, adding algebraic terms. Firstly, we need to talk about what like terms are, and you've probably seen this before, but I'll just explain it again. Like terms have identical pronumeral, so the letter parts. Okay, so if you're looking at two terms, you have to look at the letters. If the letters are identical, then they're like terms, and we can only add and subtract. Remember, adding and subtracting are the same things, but just in a different way. Only add and subtract like terms. This is the important thing to remember. Okay, if you follow this, you'll be okay. Okay, we can only add and subtract. So let's just have a think about this. So 7x. Let's just have a think about 7x. I'll just write a bunch of terms, and we can see whether they're like terms or not. I'll just circle some stuff. Okay, so I should just be writing down whatever. Square root of y. What else is interesting? 14, that'll do. How about negative 14 just to make it interesting? X, y squared, 2y squared x, y, x down here, and how about just 40y. Okay, let's just think about, out of these 10 terms that I've just written down, which ones are like terms? So all you do, let's look at 7x. Let's look at the pronumeral part. It's just x. Do any of these other terms just have x as their pronumeral part? Nope, that's got a y. Nope, that's got an x and a y. It has to be identical. Nope, that's x squared. No, 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 no. So none of these are like. So I'm going to circle that in red, and it's by itself. There's no like terms with that. I'll go to green, and let's do 2y. The pronumeral part here is just y. So let's have a look at these. Do any of these have a like term with this? This is xy, this is x squared. This is the square root of y. Now, if you know this, this is equal to y to the power of a half. Okay, this is different to y. So don't be fooled by that. That is not like term with y. That's the y to the power half. It's a different power. So no, no. Yeah, here we go. 40y has just a y as the pronumeral part, so they are like terms with each other, and that's it. Okay, so I'll go to a different color, maybe yellow, and so yellow. Let's do this 21xy. 21xy, we're just looking for some that have terms that have pronumeral parts x and y. X squared, no. Root y, no. No, no, because that's xy squared. It's different to xy. No, no. Oh yes, this is. Now this is in different order, but order doesn't matter when you multiply. So this is in fact the exact same thing. This is the same thing as xy, which has the same pronumeral part as this. Okay, I'll go with blue. Here we've got 2x squared. Do we have any other x squareds here? No, 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 no. No x squareds. So he's by himself. We'll go with pink next. Square root of y. Is there anything else with a square root of y? No, so he's by himself as well. It's a bit unfortunate. We'll go with this poo brown diarrhea colour, and we've got this negative 14. Now that's just a number. It's just a constant, and so you can only put that together with other constants. There's no other terms here that are constant. They're just numbers, so that lives by itself as well. We'll just go to light blue, and we've got xy squared. Is there anything else with an xy squared? In fact, here we have, even though it's written in a different order, the pronumeral part here is xy squared. Okay, so that is a like term with that. Now, just make sure that you understand that when this says, this means up here 2 times y squared times x. So that squared belongs to the y. Okay, don't think that that squared belongs to that x. So there you go. That's a bit about like terms, and now let's just do an example. So example, let's do a plus 3a minus 6 minus 4a. 4a plus a minus 1. Gee, I just got a bit carried away then, I just kept going. Okay, so what are our like terms? Like terms, let's circle them. Here we've got an a. Here we've got positive 3a. Okay. Here we've got negative 4a. Here we've got positive a. And what's left over are all constant terms. We've got negative 6 and negative 1. So we just have to figure out, if you put these all together, what do you get? Okay. So we've got 1a plus 3a, that's 4a. Minus 4a, it's 0. 0 plus a, and you end up with just a for your a's. Okay, so we're just adding up all the different a's that we have. 1 plus 3 minus 4 plus 1. And you just need to put your constants together. You've got negative 6 here, minus 1. Negative 6 minus 1 is negative 7. And so that is your answer there. Okay. Another example, and I'll make this my last example. Something like negative 17 plus 4y squared minus 8x plus y squared plus 1 and minus xy squared. Okay, so let's just circle our like terms. Okay, here we have a constant. Do we have any other constants? Yes, here we do. We've got a positive 1 as a constant. So you're always looking for the sign in front of the number or the premium. Okay, that plus belongs to that 1. That negative belongs to that 17. Please get that right. Super, super important. Here we've got a positive 4y squared. Do we have any other y squareds? Yes, we do. There's a positive 1 y squared. Do we have any other y squareds? Isn't that one there? No, it's an xy squared, not to be confused. And in fact, everything else in there does not have any partners. There's got this negative 8x there, but there's no other x's here. And we've got this negative xy squared, but there's no other xy squared. So in fact, they cannot be simplified. So all we have to do is put things together. We've got negative 17 plus 1 is negative 16. And then we've got 4y squared plus y squared is plus 5y squared, and all the rest cannot be simplified. Minus 8x minus xy squared. And that's all you can do. You can only add and subtract like terms. So none of these remaining ones are like, so that's all you can do. Hope that makes sense. See you in the next video.